Welcome to David Alexander Maths Tuition. This is chapter 4a, expanding 1 plus x to the power of n. Okay, so let's take a look at the first example. So we want to expand 1 plus x to the power of -5 up to and including the x cubed term. Now the first term in the sequence is 1. Now the second term is -5 multiplied by x, so minus 5x. So the first two terms are very easy. Okay, now the next term is a bit harder. So what we're going to do is it's going to be -5 multiplied by 1 less than -5, which is -6, and that is going to be times by x squared, and that is going to be over 2 factorial. So I would write 2 factorial like that, but since 2 factorial is just 2 times by 1, 3 factorial is 3 times 2 times 1, 4 factorial, 4 times 3 times 2 times 1, and 2 times 1 is 2, so rather than write 2 factorial, I'm just going to write 2. And the next term is -5, take away 1, -6, take away 1 again, times -7, multiplied by x cubed over, this is 3 factorial, and 3 factorial is 3 times by 2 times by 1, so I, as a habit, just write 6. So if we tidy it all up, that is 1, take away 5x, -5 times -6 is 30, x squared over 2 plus 15x squared. And I can, for the x cubed term, I can see that cancels. So 5 sevens are 35, so it's 35x cubed. It's just a question of what the sign is. Well, I've got 3 negatives, so that will be minus. There we go. So I've expanded up to and including the x cubed term, so it's 1 minus 5x plus 15x squared minus 35x cubed. That is an approximation of 1 plus x to the power of -5. And sometimes you get asked the range of values for which the expansion is valid, so it doesn't work with any value of x, only certain ones. So here, as it's singular x, we just write that the modulus of x must be less than 1. So what that means is x is between 1 and -1. But you can just write the modulus of x is less than 1. So that's kind of a standard answer for this one. If it's an x here, just put modulus of x is less than 1 and you're done. Okay, so a similar question here, except it's to the power of a half, not a negative number, but the first term is 1, the second term is 1/2 times by x, so that's plus 1/2 x. The next term is going to be 1/2 multiplied by 1 minus a half, which is a minus a half, multiplied by x squared over 2, and the next term is 1/2 take away 1 multiplied by minus a half, take away 1 multiplied by -3 over 2, and that is multiplied by x cubed all over 6. So that's going to be 1 plus 1/2 x. Okay, so 1/2 times a half. I'm not going to stress about the sign just yet. So it's 1 divided by 2 divided by 2 divided by 2 again. So that is 1/8. And there's only one negative sign, so that is -1/8 x squared. And what about this last one? So 3. So what I tend to do with the fraction ones is just do 1 times 1 times 3, divide by 2, divide by 2, divide by 2, divide by 6. Obviously, I probably wouldn't type 1 times 1 to begin with. So on my calculator, I'm just doing 3 divided by 2, divided by 2, divided by 2, divided by 6. And I'm getting 1/16. So that is 1/16 x cubed. And how many negative symbols do we have? 1, 2. So that is plus. There we go. And again, it's just 1x, so the modulus of x is less than 1. That is the range of values for which the expansion is valid. In other words, it only works when x is between -1 and 1. Okay, so hopefully we're getting the hang of this. So the first term is 1, the next is -3 over 2x, the next term is -3 over 2 multiplied by -5 over 2, x squared over 2, plus -3 over 2, -5 over 2, -7 over 2 x cubed over 6. So that is 1 minus 3 over 2x. So I'm just going to do 3 times 5 divided by 2 divided by 2 divided by 2. And that's positive because there's 2 negative symbols. So that is plus 15 over 8x squared. And for the x cubed, I'm going to do 3 times 5 times 7 divide by 2, divide by 2, divide by 2, divide by 6, and that's negative because there's 3 negative symbols there, so minus 35 over 16x cubed. There we go. And again, it's just 1x, so the modulus of x must be less than 1. Okay, so here's a slightly different example, only because it's a 3x here, but it starts off exactly the same. 1 minus 6x, so minus 2 times 3x, plus minus 2 times by minus 3. Here we need to be careful. It's 3x in brackets all squared over 2, and the x cubed term is plus minus 2 minus 3 minus 4 3x cubed over 6. Okay, so that is 1, take away 6x. This positive 2 will cancel out with this minus 2 and that minus sign. So here this is where we need to be careful. It's 3x all squared, so that is 9x squared. So 3 times 3 times another 3, so that is plus 27x squared. And I've also spotted here minus 2 times minus 3 is positive 6, so that will cancel with that. So it's negative 4, well, it's 4 times 3 times 3 times 3, and that's going to be negative. So that is minus 108x cubed. So we just need to be careful when we're doing the squaring. We're not just squaring the x, we're squaring the whole 3x, or cubing the whole 3x. Now, the range of values for which the expansion is valid is slightly different. Instead of it being the modulus of x is less than 1, the modulus of 3x must be less than 1. That means the modulus of x must be less than 1/3. So it only works if x is between minus 1/3 and positive 1/3. But that is the answer. The modulus of x must be less than 1/3. Here's another example. The only reason I've included this one is because it's a minus 2x. So the first term is 1, the second term is 2/3 times 2, 4/3, so minus 4/3 x, plus 2/3 times by minus 1/3. Now here it's not 2x squared, it's minus 2x squared, and that is going to be over 2, plus 2/3 minus 1/3 minus 4/3 and minus 2x all cubed over 6. So the first two terms are done. 1 minus 4/3 x. Now for this next one, I just need to remember to multiply this 2 twice. I'm going to ignore the negative signs and deal with that at the end. So I'm going to do 2 times by 1 times 2 times 2, divide by 3, divide by 3, divide by 2. And that is 4/9 x squared. And how many negative signs have I got? Well, I've actually got 3 because this is squared. So 1, 2, 3. So that's negative overall. Now for the x cubed term, I'm going to do 2 times 1 times 4 times 2 times 2 times 2. Divide by 3, divide by 3, divide by 3, divide by 6. And that is getting me 32 over 81x cubed. And we have 1, 2, 3, 4, 5 negative signs in total, so that will be minus. There we go. So the range of values for which the expansion is valid is the modulus of 2x must be less than 1, so the modulus of x must be less than 1/2. So it only works if the x values are between minus 1/2 and positive 1/2. Okay, here's another example. This time we've got some nasty fractions in front of the x here. In fact, a nasty fraction up here as well. So the first term is 1. The second term is minus 2/3 times minus 3/4. So that's going to be plus. So that's going to be plus 6 over 12. So that's plus 1/2 x. Plus minus 3/4. Take away 1 minus 7/4. And here it's negative 2/3 x all squared over 2. And the x cubed term is minus 3/4 minus 7/4 minus 11/4 minus 2/3 x cubed all over 6. So the first two terms are sorted. So 1 plus 1/2 x. So what I'm going to do now is 3 times 7 times 2 times 2, divide by 4, divide by 4, divide by 3, divide by 3, divide by 2. So that is 7 over 24 x squared, and that is 1, 2, 3, 4. That's 4 negative, so that's positive overall. And for the x cubed term, 3 times 7 times 11 times 2 times 2 times 2, divide by 4, divide by 4, divide by 4, divide by 3, divide by 3, divide by 3, divide by 6. And that is 1, 2, 3, 4, 5, 6 negative, so that's positive as well. So that's going to be plus 77 over 432 x cubes. So here it's valid if the modulus of 2/3 x is less than 1. So what do we do here? So we just multiply by 3 and divide by 2, so therefore the modulus of x must be less than 3/2. So this is a question that might cause some problems, so we need to expand this using the binomial expansion up to and including the x cubed term. Now the problem is, well, we've got a bit of a fraction, but what we can do is we can write it as 1 plus 3x multiplied by 1 minus x to the negative 1. We're going to expand this using the binomial expansion, and then afterwards just multiply it through by 1 and 3x. So first of all, the first term is 1. Negative x times negative 1 is plus 1x. Now the next bit of the expansion, as usual, is going to be plus minus 1, minus 2, negative x squared all over 2, plus negative 1, negative 2, negative 3, negative x cubed all over 6. Minus 1 times minus 2, that will cancel with the 2, and minus 2 minus 3 will cancel with the 6, which is nice. So it's going to be 1 plus x squared. We've got negative x cubed times negative 1, so plus x cubed. Now I've expanded that up to the x cubed, so I'm going to multiply it by 1 plus 3x. So if I multiply it first of all by 1, well that's nice and easy. That's just going to be 1 plus x squared plus x cubed. Now multiplying by 3x, 1 times 3x is 3x. X times 3x is 3x squared, and x squared times 3x is 3x cubed. I've also got 3x to the 4, but I'm only going as far as x cubed. So if I just add all of this together, you don't have to write it in line like I do. I do it like this just because it just makes the adding a bit easier at the end. But you can write it in one long line if you want. There we go. So 1 plus 4x squared plus 4x cubed, which is what we were after in the first place. Now, what's the range of values for which the expansion is valid? Well, this is the bit where we're doing the binomial expansion, so it's just the modulus of x is less than 1. Okay, so here we need to expand the f of x, which is the square root of 1 plus 2x. In other words, 1 plus 2x to the power of 1/2. So the first term is going to be 1. 2x times a half is plus 1x, plus 1/2 times minus a half, multiplied by 2x squared over 2, plus 1/2 minus 1/2 minus 3 over 2, 2x cubed over 6. So the first term is, we just write it up here, 1 plus x, that's nice and easy. So 1 times 1 times 2 times 2 divided by 2 divided by 2 divided by 2, that is minus 1/2 x squared. And 1 times 1 times 3 times 2 times 2 times 2 divided by 2 divided by 2 divided by 2 divided by 6 is also 1/2, and there's 2 negative signs, so that is going to be positive, so plus 1/2 x cubed. 1 plus x minus a half. Perfect, great, so that works. Okay, so this is a slight random question here, but we need this for the final part. When x is 100th, so 0.01, what is the exact value of we'll show that the exact value of the f of x is root 102 over 10. Okay, so 1 plus, now 2 lots of, or 2 hundredths, or 2 times 100th is 2 hundredths, or 1 over 50, and 1 plus 1 over 50, that is 51 over 50. Now the square root of 51 over 50, I can write that as the square root of 51 over the square root of 50, which is the square root of 51 over root 25 root 2, so 5 root 2, which is root 51 root 2 over root 2 times root 2, which is 2 times 5, which is 10, which is root 102 over 10. If you just whack it into your calculator, it automatically takes you there. There we go. Okay, right, I'm just going to delete the ink, so I've got a bit of space to do the final part, which not terribly difficult. Okay, so calculate the percentage error in using the series expansion to estimate the value of the f of 0.01, which is 1/100th. Okay, so we know the exact value should be root 102 over 10. Now, on my calculator, I'll just write down what it says. Now, that is 1.00995 0494. So that is the exact value. Now, what happens if I type in 0.01 into my expansion? So 0.01 equals, clear, 1 plus answer minus 0.5 answer squared plus 0.5 answer cubed. Using the expansion, I'm getting 1.009950. Okay, so they're pretty similar, really. And this one's a tiny bit bigger. So to work out the percentage error, it's just the difference divided by the exact multiplied by 100. And as we can see, the difference is so minuscule. I'm going to probably end up with a ridiculously small percentage. So what is the difference between 1.0099505 and the other one, minus 1.009950494? So that is 6 times 10 to the power of, I think it says -9. So I'm going to divide that by the exact value, which is the 1.009950494. Could actually just type in root 102 over 10 if I wanted to, and then multiply that one by 100. So what I'm getting is a percentage error of 5.94 times 10 to the -7, or 0.123456594%. So the percentage error is minuscule. So even if we do use the expansion, even though we haven't gone as far as doing the x to the 4, x to the 5, x to the 6, even if we just by going up to x cubed, we're only, well, we're hardly, it's not massively inaccurate. It's pretty darn close, isn't it? So there we have it. Okay, here's another example where we don't know what a is, but we do know that the coefficient of x squared is -9/8. So let's just do our expansion like we would normally do. So that's going to be 1 minus 1/2 ax plus 1/2 minus 1/2, and that is ax squared. So the a will be squared as well, over 2. And we need coefficients for the x cubed term, so I'll take it as far as that. So plus 1/2 minus 1/2 minus 3 over 2 ax to the power of 3 over 6. So what I've got is 1 minus 1/2 ax. Okay, so I'm going to do 1 divided by 2 divided by 2 divided by 2. So that is going to be minus 1/8. Now it's not ax squared, it's a squared x squared. We are squaring a and x. And if there was a number there, if it was 1 plus 3x, then we would be turning a 3x into a 9x squared, not a 3x squared. And for the final term, that's going to be a cubed x cubed. So 1 times 1 times 3 divided by 2 divided by 2 divided by 2 divided by 6 is 1 over 16. I've presumptively put in a plus. Is it positive? Yeah, because you've got 2 negative signs. Okay, so the coefficient of x squared is -9/8. So what I can say is that minus 1/8 a squared x squared equals minus 9/8 x squared. In other words, minus 1/8 a squared equals minus 9/8. And we can just multiply through by 8 to get negative a squared equals -9. So a squared equals 9. So a is the square root of 9. So a is plus or minus 3. So the possible values of the possible values of a is plus or minus 3. Find possible coefficients for the x cubed term. Okay, so the x cubed term is 1/16 a cubed. So let's go with positive 3. So 3 times 3 times 3 divided by 16 is 27 over 16. And minus 3 times minus 3 times minus 3 divided by 16. Well, that's obviously going to be minus 27 over 16. So with this sort of question, just a bit of problem solving really. Just make sure you are squaring the a as well as the x, and then it's just a question of equating stuff and, well, going from there. Not crazily difficult. Okay, here's one last example. It's got something a little bit strange later on. So let's do our usual expansion. So it's 1 minus 1x plus 1/2 times by negative a half multiplied by minus 2x squared all over 2 plus 1/2 minus 1/2 minus 3 over 2 negative 2x all cubed all over 6, and that will give us 1 minus x minus 1/2 x squared minus 1/2 x cubed. Okay, so next part, show that when x is 0.005, the exact value of 1 minus 2x to the power of a half is 3 root 11 over 10. So what is 0.005 multiplied by 2 is 0.01, and 1 minus that is 99 over 100. So what we have is the square root of 99 over 100. So that is root 99 over root 100, which is 10. And that is root 9 root 11 over 10. So 3 root 11 over 10. Okay, so for this final part, let me just delete everything, and I'll just rewrite the expansion. It was 1 minus x minus 1/2 x squared minus 1/2 x cubed. Okay, so we are saying that 1 minus 2x to the power of 1/2 is approximately the same as 1 minus x minus 1/2 x squared minus 1/2 x cubed. Okay, so, and we know that when x is 0.005, so if I'm substituting 0.005 into either of these, we should get more or less the same thing. And we're saying that it was 3 root 11 over 10. So 3 root 11 over 10 is approximately 1 minus x minus 1/2 x squared minus 1/2 x cubed, only when x is 0.005. Okay, now if we want an approximation for root 11, we are going to have to fiddle this, because this is, I can't substitute 0.005 into this equation, because that will give me 3 root 11 over 10, and we want an approximation for root 11. So what I need to do is I'm going to multiply this through by 10 and then divide through by 3. Okay, so root 11 is approximately 10/3 of 1 minus x minus 1/2 x squared minus 1/2 x cubed when x is 0.005. Okay, so I'm going to type into my calculator 0.005, and I'm going to do 1 minus answer minus 0.5 answer squared minus 0.5 answer to the power of 3 equals some stuff, multiply by 10, divide by 3, and I am getting 3.3166 to 4 decimal places. I can test my answer. What is the square root of 11? It should be fairly close to 3.3166, and I'm getting 3.3166. Maybe I should have looked at some decimal places beyond that, but we can see it has worked. So we can always test our answer. Is what we're doing here, does it actually work out to what the decimal equivalent of root 11 is? And in this case, we got it pretty much bang on. So we know I've definitely got the question right.